Hello class, welcome to the 20 video of chapter 4, video yang ke-20. And in this video, you need to learn about the transition elements. Okay, now go to the next slide. Where transition elements are located. Yes, transition elements are placed from Group 3 until Group 12，从 Group 13到 Group 12。All these elements which place in Group 3 until Group 12 are known as transition elements. Please remember the name of the elements which are placed in Group 3 until Group 12 in the periodic table. And the examples. These are some examples of transition elements which are Cr, Mn, Fe, and Cu. Okay, and now in figure 4.16, the yellow portion. The yellow portion show the position of transition element. Let's look at the next slide. Okay, yes, the yellow position means is. These are the example of the transition elements, and this is Cu. And where is Fe? Yes, this is Fe. So Cu and Fe are the examples of transition elements which located in group 3 until group 12. Okay, now this slide is habis cerita. We go to the next slide. All transition elements have the following properties. 这些是很普遍的 properties. Because transition elements are metal, so they are solid with shiny surface. I repeat, transition elements are metals, so they are solid with shiny surface, and they are very hot if compared to metals in group 1 and group 2. Group 1 is alkali metal. Alkali metal is a soft metal. So when compared to transition element, group 1 metal and group 1 metal are softer. However, transition elements are harder when compared to group 1 metals and group 2 metals. And transition elements have high density and also have high melting point and boiling point. These are the ordinary properties of transition elements. However, transition elements are quite special. Why? Because transition elements have special characteristic. Yes, in the whole periodic table, only transition elements have special characteristic. What are the special characteristics? There are total 4 special characteristics of transition elements. Now we go to the first. The first special characteristic of transition elements is transition element can function as catalyst to increase the rate of reaction. In chemistry, we know as catalyst. That means in chemistry, we use the term of catalyst. Catalyst is a substance that can speed up the rate of reaction. 它可以加快那个 reaction 的速度。But in biology, we call this substance as enzyme. 在 biology 里面 we call the substance which used to speed up the rate of reaction as enzyme. But in chemistry, we call this substance as catalyst. And for example, iron filings used in Haber process. You must remember at least one examples of catalyst. And here I encourage you to remember the first one, which is iron. Iron is an example of transition element, and iron is function as catalyst in Haber process. Haber process is a process used to manufacture the ammonia. And next is the first special characteristic of transition element is habis-cerita. We go to the second special characteristic, which is transition elements form color ions or compounds. That means the ions of transition elements or the compound which contain transition elements has special color, has different color. And do you need to remember this table? Yes. You better remember the color of the transition elements ions. And first one, Cr3 positive, green color. And dichromate 6 ion, orange color. And manganese 2 ion, pink color. And manganese 7 ion, purple color. And iron 2 ion, green color. And iron 3 ion, brown color. And the last one, copper 2 ion, is blue color. These are the color of the solution where these transition elements ion dissolve in the solution. Okay, now we go to try to answer this question. The first one, what is color of chromium 3 chloride? Chromium 3 chloride, as you can see, chromium 3 ion present in this compound. So we go to check chromium 3 ion. When there is the presence of chromium 3 ion, so the color is green. So this answer is green color. And now, how about potassium dichromate 6? Potassium dichromate 6, because of this dichromate 6 ion, so is orange color. This one is orange color. And how about manganese 2 chloride? Manganese 2 chloride are here because of the presence of manganese 2 ion, so is pink color. And how about this manganese 4 oxide? This one, please jot down, is black color, 它是黑色的。And how about E? Potassium manganate 7 is, yes, here, purple color. And now, iron 2 sulfate, because of the presence of iron 2 ion, so is green color. And next, G, iron 3 chloride, because of the iron 3 ion, so is brown color. And the last two, how about copper 1 oxide and copper 2 oxide? Yes, the answer is copper 1 oxide. This compound is red color. Please jot down. Copper 1 oxide is quite special. This is red color. And copper 2 oxide, although copper 2 ions present in copper 2 oxide, however, copper 2 oxide is not blue color, but copper 2 oxide is black color. So please jot down and remember this. Copper 2 oxide is very special because copper 2 oxide is black color. So this slide is habis-cerita. We go to the next slide. This slide shows the third special characteristic of transition elements where transition elements have more than one oxidation number. What is oxidation number? Oxidation number, the value of oxidation number depends on the charge of the ion. For example, we look at iron. There are two different ion, which is iron 2 ion and iron 3 ion. Iron 2 ion is Fe what? Yes, Fe2 positive. Because of the charge is 2 positive, so the oxidation number is positive 2. And the iron 3 chloride, where the formula of iron 3 ion is Fe3 positive. So Because of the charge is 3 positive, then the oxidation number is positive 3. We use example of iron. And this example can explain where transition elements have more than one oxidation number. Okay, this slide is theoretical. We go to the next slide, where this slide shows the last special characteristic of transition element. Transition elements can form complex ion, very complex, until you cannot memorize the formula of the ion because it's too complex, too complicated. But I encourage you, I advise you to memorize at least one complex ion of transition element. 你自己选一选 which one you can memorize. At least one. Remember, at least one. Okay, this slide habis cerita. We go to this slide. Again, this slide is talking about the uses of transition elements in industry. They always function as catalysts. What is catalyst? Catalyst is a substance which can speed up the rate of reaction, 可以加快整个 reaction 的速度 and commonly used in industry because want to produce a large amount of yield in a very short time. So usually we'll use catalyst to speed up the rates of reaction. And I advise you to memorize at least one example of catalyst of transition element. So I encourage you to memorize this example. And there are another, which is platinum. Platinum is used in Oswald process. Vanadium 5 oxide used in contact process, and nickel or platinum used in hydrogenation process. And this slide habis cerita. We go to the next slide. Another uses of transition element. The first one, manganese, used to make stained glass windows different color with different color. Because transition element can form color ion or color compound. And the next one, iron. Iron is transition element which used to build the bridge, 铁桥. And titanium used to make paint, different color. Okay, this slide habis cerita. We go to the discussion of the question. This table 4.13 show the transition elements that exist in gems, 钻石, and with different color, ruby, all this gem has different color. So what's a special characteristic of transition element shown in table 4.13? Yes, can form color ions, 不同颜色的钻石、宝石. And next, we go to the B question. Apart from the characteristic given in 1A, when you answer A, the answer is form color ions. Then, other than form color ions, is there any other special characteristic found in transition element? Yes, have different oxidation number or form complex ion. And next, the last question. Give example of several transition elements used in industry. As I mentioned earlier, you must memorize at least one example of catalyst of transition element, right? So you may use this. Iron used as catalyst in Haber process. So this slide is the last slide for this video, and this video is also the last video of chapter 4. Bye.